always have the weirdest beginning to these streams. I'm always staring at some weird direction. Well, let's do this real quick. Alright, well that's out there. I think I can probably get rid of a few things here so we can keep a better eye on what's going on. So I need things. I need to make some parts for this thing. This is an old spectrum analyzer set from HP, the 8568B set. There's some unusual bits. We need some special interconnect cables built here. This coax one. These are all pretty common BNCs, so no big deal there. And wow, just noticed that my pointer is off. Let's see if I can fix that. It should be doing it, but it's not. Oh well. Maybe because I'm not focused on it? Ah, there we go. New things to learn all the time. So these are BNC connectors, easy enough to get by HPIB connector or GPIB. This one I don't actually need right now, but it would come in handy. This one's kind of hard to get. These connectors. This is a sub-D connector, kind of like a VGA connector for your monitor, old style connector, or old serial port or parallel printer port, things like that. Both of these are D sub miniature. This one though just happens to have 5 coax. It's the DB5W5 connector with 4 of the coax inserts in there. This one down here is a 50 pin DD50. This one I can make, surprisingly, and I can probably get the connector for about 200 or 300 yen. Not too bad. This connector, on the other hand, is $250, or Nihon Gosen yen. It's a lot if you don't build it yourself. But this is a standardized connector, and I can find the housing without the coax pins in it, so that basically 5 number 8 holes. All the other pins are available inexpensively, but the coax ones are kind of special. They were used in some old VGA monitors, or not VGA, some old video monitors for specialized systems. They had 3 of these connectors in it, so those cables are a possibility. In the US, I could buy a cable with those in it for about $13. In Japan, $70, 7,000 yen. It's crazy. The pins are made by ITT Canon, and apparently only ITT Canon. Maybe Farnell has them, but right now each pin, one of these little gold things here, selling from the manufacturer for like $25 each. Using Go Hyokuin. So that would make that a really expensive connector to make myself, because I need 10, well, technically I only need 8 pins, but I would put 10 in it to make it universal. Yeah, and then the connector housing itself, again, 400 yen, $3 or $4, nothing crazy, uh, just those pins. So either I need to scavenge those for something, or make one, and I can get those center contacts. It is a 50 ohm connector for a 22 megahertz approximately signal, so it's got to be pretty close. But it turns out one of these ferrule connectors happens to be exactly the right size to go in there, so maybe I can find a way to use that as the shield over some bare coax with a center pin soldered on. It's possible. I've got some ideas. I'm not sure if that's going to work. I'll test it out, see if it does. I don't know. The other part is, so this cable connects to here. A nice little short cable, about 20 centimeters, I think. 20-25. This one connects to here, and they're both 50 pins. It's not exactly a one-to-one pin out, but that's only because these two connectors are numbered differently. Otherwise, it's actually one-to-one. Like I said, this is a DD50 connector, same sub-D series, just a D shell instead of the B shell like this one. But this is a Centronics 50-pin connector, also called the micro ribbon or rack and panel connector sometimes. Trapezoidal rack and panel connector, maybe. I've seen that thrown around. But it's Centronics 50. It's used by SCSI 1, maybe 2. I don't know a lot about SCSI, which is a interconnect for older computers. I can get that connector as well. That's fairly common. This one This one carries digital I/O between these two systems. Things like the part of the keypad matrix for all the keypads here. So these two systems share like a bus, a data bus. The keypad down here takes up most of the matrix, but this is also integrated into the same keypad matrix as this, so it needs some columns and row pins to connect these two keypads. There's some just simple indicator ones as well. Then there's a data bus and an address bus. Not the whole bus, it doesn't need all of it, just parts of it. What else was in there? A few basic signaling pins and a horizontal sweep, I believe, which is important because that needs to be broken out. One goes this way, one goes into here, the horizontal sweep. That gets broken out to go to the this device, which is a pre-selector. Basically, it filters. It has a bunch of different filters for different bandwidths, so you can look at specific parts without being overwhelmed by all the different frequencies that it looks at. I suppose I didn't say what a spectrum analyzer does, but it analyzes frequency spectrum. This measures the voltage frequency. So it measures voltage as it changes over time, which is the typical frequency that you're familiar with, if you are at all. This device up here is the quasi-peak detector, which is used for some EMI testing, electromagnetic interference testing. There's a few standards that this matches, and it can do that. I don't need that part right now, but it'll be kind of fun to play with later. This was all really cheap. I bought it on Yahoo Auctions. I could get most of the stuff. The spectrum analyzer here was actually the most expensive part, about $50 goes in, because you have to have that. It's a shared part. This display is used by a couple different systems. So even though you need the display to make this part work, which is the RF section, the actual, this does the, I guess they both do it together. The spectrum analysis, really. This does it for one set of frequencies. This does like some common parts. So somebody really wanted this one. It went up in price a bit, but I wanted the whole set, so I ended up getting it. The rest of the parts, like the top and bottom ones, were really cheap, $10, 1,000 to 1,500 yen, I think, for the pre-selector and the quasi-peak adapter, because you don't need those to make a working system. And this part down here is the less desirable spectrum analyzer, the RF section, because it only goes to 1.5 gigahertz. The one that most people want is like the 22 gigahertz version, and I can see why, but yeah, I don't, most of my lab is set up for 2 gigahertz and under, honestly, really under 1 gigahertz. And if I go over that, I've got some software-defined radios that have transmit and receivers built into them that you can actually use for a lot of RF level stuff. Anything 2 to 6 gigahertz. With that pair, I can use a computer to do the rest of the work of turning it into a spectrum analyzer or a high-frequency oscilloscope or all kinds of other things, with some limitations. So what I need to do, though, is these devices are stacked on top of each other, like this thing here. And in the back of them, they have these little feet that help hold everything together. Where is it? And that's what we're going to model today. These things. These are made of metal. They don't hold any weight. Like, they're not structural. They are a bit structural. They keep things from shifting around. But like the top one usually on one device mates with the bottom one, and it just locks it in place so you can screw it down. It keeps them from slipping around on the back, since you probably don't put feet on it to keep it more secure. But normally they would have it like a set of feet that go on the bottom of the instruments that lock them together and make them not slide around. But to make this more compact, you get rid of those, and this does a similar purpose. So there's also, you can't see it and I don't have a way to show you right now, but on the front of the device up here, between them, there is a little ledge also that needs some hooks to help keep things from slipping around as well. So that's what we're going to model today, is those things. If we have to. First, we're going to look up to see if they already exist. So we'll go to a couple of the go-to places. Did I close that window? Nope. Here we go. Actually, I might be able to show you. Let's look through some of the gear here. Need all those pictures. And I don't have a good picture of them stacked up. That was the oscilloscope work from yesterday. You can see some of the pins, but not very well. I know I've got a good view of these stacked somewhere. No, I edited them down already, so you can't really see it. Oh well. So first thing we need to do is see if it exists already. So go to my two go-to places to find models, which is printables.com by Prusa Printers. Let's just look for the spectrum analyzer first to see if anything exists. There is an actual part number for that, but for some reason I'm guessing it doesn't actually, won't help me find it. We could try to look that way. Nope. Let's see if there's anything Hewlett Packard. There is some, but in this case, it's not what we, oops, 380 more. Let's see. There's some feet for not HP instrumentation, but for another line of work. No, I don't see anything. All right, let's check Thingiverse. For which, let's look for HP feet. It's probably a bad idea to search for feet. Here's some of the standard feet. These are for the small portable equipment to make them stand up. There, ooh, I do need those actually. The back bumpers on some things. Ah, look, they have already actually modeled some parts. These don't do everything I need, like they don't do the interconnect. Nice, okay, let's open that up. But they are the good bumper feet, which I am missing on some of them. They allow you to stand the device on its tail, basically, which comes in handy. Let's keep looking. That looks similar to that other one. Ooh. I want to see what they're doing there, but it's not what we need. I mentioned, not here, but on my Mastodon account, I had mentioned something about my videos, my old ones, all looking very tired and old. And I realized that I had auto white balance turned on my camera, which makes everything look like this. The video that I saw was not this. The video I was seeing looked more like this. Well, it will look like this whenever it gets going again, which is a lot better. It might not be perfect actually. But apparently my green hat was throwing everything off. And my anti-flicker is set to the wrong setting. So that looks a lot healthier. It's not great. My lighting needs a lot of work, but it's certainly better. So auto white balance off, and that's much nicer. Okay, back to searching for parts. Looks like we've looked through everything HP feet. So let's take a look at individual things. Yeah, I like these. They have the hole in the right place, which is important. That would keep me from needing to measure. And they got some geometry worked out already, so I like that. I can modify it. It doesn't have the locks on it, so I'd have to modify that, which is just fine. Those actually look like, is that a... Nope, it's not a copy. It's just another version. It looks, I don't know. I think it's just the color. They look a little... Yep, it's just the color. This one looks a little more refined. Maybe not. They're very close. I think it's just the color throwing me off. Okay, how about this one? Same deal. An extended version, so long feet, which might be necessary. No, I don't think I would need the long foot version. These look pretty standard length. Okay. Good to know, though, that other people have done the work. So let's see what this person did. What did they build? A new faceplate, possibly? They replicated a part with decals or decals, depending on where you're from. Oh, I do need to do that for my LaCroix oscilloscope. All the cosmetic plastic on the front has crumbled. It got very brittle. And I need to, oh, nice. Good job. Looks like some battery holders for standby power on probably something really important. Good job to Mark Greco. That looks really nice. A digital clock and a real actuator. So it's probably for this digital clock. Nice. Excellent work. I'm going to have to come back and look at that. That's not why we're here today. Do we want to model this, take this and modify it, or make our own? I think we'll just make our own. They look similar, but this one needs, it's not quite as simple, I don't think, as taking one of those existing pieces and chopping it up and then adding a few other ones. So we're just going to model it. We got the time. Why not? Yeah. Okay. So to do that modeling, I'm going to keep those just in case I need to go look at them and reference them. We're going to go into Tinkercad, tinkercad.com. You can log in. You can create it. It's free. Use your Google account if you feel like it, or Facebook. I think a couple other ones, or use an email account, which is my recommendation. No need to link everything together. Yes, it makes login easier, but if something happens to, that's another topic. Let's just make a new part. And I should look up the part numbers for these. So you have no idea what I was just doing because you couldn't see that. Oh well. Let's find another part. Where did I put the thing? Always losing the thing. Okay. That is the HP. I need to look up the part number, which means I'm going to open up the user manual. Installation. Let's try the installation and verification manual. That always seems like a good, has some good stuff in it. All right, let's turn that back on. There we go. Make that a little bigger here. Other manuals, yep. Accessories supplied. Hopefully that's it, but we'll look. 1, 2, and 1, 5. I don't think that's in there actually. I think it's in the replaceable parts list at the end. Let's see. Verification. Well, let's find out. 1, 2. So there's the stack. They number some things, but they don't talk about it. All right. Options, kits. They did have a rack mount kit. So since these are extra parts for mounting in different ways, but the default is with the feet on the back and the thing. But I know I've got a book that has those in them. So let's power through and find what they're called. Nope. Wow. This guy's having a lot of fun. Cleaning. I don't need to replace the battery. Why don't you? This is the installation manual. Why don't you tell me how to install it? We got foam pieces. That's good to know. This thing is crazy heavy. Look at that. 159 kilograms or 350 pounds. That's for both pieces, I think. It's ridiculous. It's a tank. Hopefully preparations for use includes putting the feet on. Yeah, they're already installed by default. So we're putting some cables on there, selecting the voltage. Oh, here we go. Putting the handles on. That's good. Does it give part numbers for the handles? Nah, that's setting up for rack mounting. It's setting up for feet. So if you're doing the information card, here's the rack mounting things. Check the fuse. More handle attachments, more feet. Okay, where's that figure? We should remove the information. Let's see, callouts 2, 3, and figure 3. What is 2? You don't mention what number 2 is. You probably just say remove number 2. Okay. Doing those, blah, 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 side panels. Yep. Putting the handle on and the rails. Here's the slide rails. Don't need those. Oh, there we go. 1 and 2. Oh, it just says remove. Excuse me. Remove 1 and 2. Doesn't have part numbers. Okay, this is doing all of that. Well, I don't think it's going to be in here, so we're going to have to go to the replace the troubleshooting book specifications, testing. Yeah, nope, not that one. All right, hang on a second. That is the Tinkercad. You couldn't see me. Couldn't see when I was talking about it. Okay, I think maybe this one. The troubleshooting and repair manual, which should include, so here's the RF section. General parts listing, right at the end of volume 1. And then major assemblies and component locations. That I think is what we need. Volume 2 has a similar thing for the IF section. Okay, both of those should have what we need. If I remember right, volume 1 ends around page 450. General parts listing, awesome. Okay. Screws, heat sinks, I don't know what they're talking about. Let's check one. Ah, here we go. There's the rear foot, number 1. Foot bottom. There's 8 of those. Why there's 2 rear foot. So the top, if I remember, at the top, left, and right are mirror images of each other and have a screw. The bottom, or no, that's the bottom. The top ones are also mirror images of each other and don't have a screw, so they would need a whole different part. And guess what? They have a part number printed right on them. Huh. Well, that was dumb. I should have just looked that up. All right. I should look at the part that I'm going to actually model. That's brilliant. Okay. Let's look up to verify HP. I go 20-89388938. You want to guess how much those feet cost? I guess you don't have to. There it is, $18 for one. I don't think that's a set. That's just one. Ah, discount, $13. All right, at least we know what we're doing. So let's go back here. This one we're going to do the simplest one first, which looks like this. Let's work on that. Which is the HP 50, 20, 89, 40 upper right foot. Actually, let's make this a little easier to see. There we go. What have we got? Let's start with the flat stuff. And I'm going to put the tapers pointing up because that's just easier to do. And so when you're modeling things, I'm going to model the original one first, which is, since it's made of metal, it's going to be thinner than what's probably needed. But if I do a plastic version that I can 3D print, I might have to beef up the parts a little bit. But that's not too bad. We should be able to do that. So it looks like, there we go. Okay, we've got the bottom plate is 23 millimeters with a wedge cut out of it. It's got rounded corners. Tinkercad's not great for doing rounded corners, so I've got to put the part in and then come back later and do some more rounding, we'll say. So it's 23 millimeters tall. It is, what do we call that part before the thing? Overall, it's 47.5 millimeters wide. I'm going to make it 48 because I really dislike fractional millimeters in Tinkercad. It makes things annoying. It's 5.5 millimeters tall. And I don't think that's critical, is that? It is kind of, but only if the back surface has to be, so here, I'm working on this part. How thick is this piece? The important part is that this back surface is a certain distance away from this screw hole. That's not too bad. We'll be able to get that. Yeah. So I'm going to make this thicker than the original, but we'll make sure to keep that dimension in mind. You can see there's actually two separate thicknesses here. There's where can you see that? There's this piece with the point on it, and then there's this extra tab that sticks out that's a little thinner. So we're going to model both of those separately. This triangle piece, which is not critical, it looks like it's about 12 millimeters. So I made that 48, but we're going to put a triangle in there. 6 tall. We need that to be 12 millimeters wide. And drop that there, make this 12 millimeters narrower. 36, that's about right. Okay. Man, I should really do the rounding part. No, it's 3D printed. I don't need to. I want to. I want it to look good. Well, how big is that? I'll say all the rounds are about 2 millimeters in radius. Oh man, that's going to be really annoying. Tinkercad makes this such a pain. Just make this 4 millimeters diameter, 6 millimeters tall again, 7 for now. See, I can't, this is one of the problems with Tinkercad, is I can't say be tangent to 2 separate lines, and I can't just say fillet this. I can't just say be rounded. That's not terrible in a lot of cases. It still gets you by. There's other tools that are out there that can do that very easily. Most of them are not free. Some of them are. And I think I could do this with a round thing. Maybe there's some other features in here that would let me do that. I'm thinking. But you know what? I don't know if I want to worry about it right now. Do I? Do I? No, I don't want to. Let's just keep going. And there's the other part that sticks out here. Let's group these together. I don't want to group anything yet. I changed my mind. All right. So we need that little extra foot, which is 3 millimeters. It sticks out an extra. Is that 12 or 13? It's 12 and a half, of course. That part is a bearing surface, so let's make it bigger than it needs to be, which will be fine because the edges aren't critical, or the location of the edges are not critical, just the top surface. It is 30 millimeters wide and it lines up exactly with the end. Okay. Now, rounding squares, although not easy, is doable. Triangles are a pain. So we're going to take, we'll do this one. Because at least I can line up the edges of things. And to do this, you end up shrinking those and just joining some solid pieces together. Actually, to make this the least number of parts, we're going to do it this way. There we go. And this will join just because I don't want to have to deal with it being a bunch of pieces. Why not? There's 2. So the only thing that isn't rounded really is that point over there, and I can file that. All right, getting going. Now, wow, I am sorry about that again. Didn't turn it on. The next part we'll need to do. So we've got this bottom piece. There's no holes in it yet. There's no features. That's okay. We'll get to that. We've got these two pieces modeled. Basically, this whole bottom piece. We're going to add this flange, this thing, and then this piece here. This one's going to be a little bit different because, well, this is square with some rounded corners. This piece is tapered. It tapers. You can't see any of that. It tapers. Well, it tapers. In a couple directions. Not impossible. We'll get there. It'll be fine. Let's just keep moving along. This time, I'll make it so you can see what I'm doing. Let's see, we need another piece. It's going to sit on top of this. It is a little over 3 millimeters wide, but we need some more beefiness, so we're going to call it 4. No, I said I was going to model it the same way first, so let's start with the original and then work our way up. It is 10 millimeters tall, 9.5, but me. It's the same 30 millimeters wide. No, I take it back. Actually, that is a part of another surface that's a little bit taller. And I'm probably going to need that too. Let's see here. What is that depth? It's about 0.5 millimeter. Is that a taper? No. 4 millimeters if I go all the way, but then it's got a cut in it. And it's not as thick as the rest of them. I am going to just model it as a block and then we'll come back and trim it out. So 34. Yeah, I'm going to trim that out and then, yeah, okay. We'll just do that. I think I'll just do it as 2 separate pieces, honestly. Yeah, I think I will, but we'll get there. Okay, that's not a taper yet, so I can still trust that. 13, almost 13 millimeters wide. For the next part, we'll come back to that other piece in a minute. 13 wide and 37.5. I'll call it 38 with the round tip on it if we do that. Look at that. By 38. All right, that is the base of the piece that tapers. So I think I'm going to build that as a block and then add a triangle onto it. And at the top it's 10 millimeters wide. So let's make this 10. And then we'll add the triangle block on the side. The total height is, that is flush with a different piece. Yeah, that's why that looks so much bigger. Interesting. That's 12. That's 10. Huh. Well, that's interesting. This needs to go all the way down to here and be 12 tall. So that's slightly different size, but that's okay. That puts me where I want to be. This same thing is actually from here. Okay, it is 25.5, but 26 is okay. Yep. Let's bring this in because we need to add the taper onto the outside edge now, which is thicker at the bottom. So it's 0 at the top and 3 at the bottom. Yep, 13. So 3. Let's put that with the other one. Yep. There's our taper. You know what I just realized? I was tapering in the wrong direction. Yeah, fun. Okay. This, yeah, that's this way. So it's thicker at the bottom. Or back. What's the best way to call that? Thicker over here. Yeah, that makes more sense now. And thinner at that end, which is, did I again make something dumb? Yes, I did. All right. Did I? No. It's the ground. So that is right. Has that? Yeah. Yep. I think. Yeah. Okay. Yeah, I did that right. Let's bring that up there. Yeah, that's right. Okay. It looks weird because I still have to chop the edges off. Which is, I need to do something before I put the bevels on everything. Or not the bevels, the rounded corners. All right. Well, that is almost it. There's one angle that I need to do, but if I do that, it's going to cause problems, I think. So let's put this in here and turn it so that, yeah, I definitely don't want to try to do the bevel. I'm just going to chop it out. I don't want to do it as a separate piece, do I? So let me show you what I'm working on next. I can turn that piece into a hole because what I need to do is this part. We're looking at, you can't quite see, we're looking at it from the other side, but this part sticking up is the blue one right there, is basically this face. I need to put this edge on it, and there's a couple ways to do that. One is I can take this, turn it into a subtract piece, which instead of adding things to it, it just chops it out. So I could do this, right? I just put that in here, stretch it to the right shape, and I chop off a corner like so. Let me just do it. It'll be easy to see. And oops, one, two, and chop. Okay, why can't I add that one? Oh, because I don't have enough pieces there. Okay. No, what is going on here? Why can I not subtract? There we go. Okay, so that just chops it right out of there, right? So now we've got that bevel, but then I've got an external radius if I want to put that on there, which would be kind of a pain. And I still have to do, yeah, that's supposed to be radius, that's supposed to be radius. I could just ignore those because 3D printing is going to take care of that for me. I could just chamfer them. That's way easier than putting around. Maybe I'll do that. A chamfer is just exactly what we did kind of here. We just chop a corner, but instead of chopping a big section out, we'll just do boop. That's a whole lot easier to do. And in the scale of this thing would look almost the same. Ooh, yeah, I like that. Maybe we'll do that. Yeah, chamfers are so much easier. I'm definitely doing that. Okay, so let's do the difference here. Let's ungroup this and turn this into a chamfer instead. So if I were going to do a chamfer, instead of doing it that with the circles and adding pieces together, I would take a triangle piece, lay down, rotate it the right direction, there we go. So as long as it stays 45, honestly, it doesn't really matter what size it is, but for convenience, I'm going to make this a little bigger than what I need, so I can place it in the right place and still be able to attach it or grab it. Oops, don't. There we go. Okay. So I could put it right here, and that's not a bad thing to do. Let's turn it into a hole first. So I could do that. That's only one. Let's see. That's one. Right, I need that to be two. So right now it's offset. I stick it out a little bit. It's really bad practice to stick things like these two surfaces together because mathematically it's hard to tell which one is on the edge. Now Tinkercad does a pretty good job of saying, oh, I know what you're trying to do. But in the real world, if you're using another CAD package, the subtract surface being in the same plane as the solid one can cause problems. It also looks weird. So let's move this down, right? You saw how this, see how it does that weird blinking? That's because the renderer doesn't know which one is on the outside. And so that could cause problems. to make that so that I can do two, I actually need to make this 4x4, and that way I can, let's put it back up a little bit so I grab it. So it should look like that, right? 2 millimeters on both sides for my chamfer, and when I put it right there, now I have 1, 2. I'm watching this gray area right here, the length. We've got right now 1 unit, well 0, 1, 2, and over here, oops, 1, 2. So now we're 2 millimeters. So I'm going to use this here. We're going to duplicate that, rotate it around a bit to get the other corner. 1, 2. There we go. Oops. Is that right? Yeah. 1. Exactly. Yeah, I'm going to use that again. So let me save it over here. These get to be grouped together and chopped. There we go. Now we've got some lovely bevels on there. We're going to do the same thing in a couple more places. Nice. Now this is a problem. But I knew that was going to be a problem. So I'm going to bring that over here. And let's take a look at this thing. I need another nice chamfer on that corner there. But I also need a fillet, which a fillet is like an inside corner when you add material. And is there a fillet? Yeah. Is a fillet round? Oh. Like a fillet would be a round cutout, and a chamfer would be a flat one. Well, I need to add some here too, but that's also called a fillet when you add it in. So I guess a fillet would still be round, but I'm adding material. In this case, I'm going to add a webbing here to well, in this case, it just makes it easier to make when the metal piece was made, but for this plastic one, it just makes it look similar, and it looks nice. Let's lay that down. Go over here. In this case, it has to be just the right size, though, because I'm adding material instead of removing it on that one. And on this one, it still needs to be oversized so I can put it in the right place. 1, 2. We're going to chop that off. Is that lined up about good enough? Okay. This one, on the other hand, needs to be the actual size so it can be added. Turn that solid again. Lovely. This one, so this part we're going to, oops, 1, 2, 3. Let's add those together. Wow, I forgot. It doesn't have to go down that far since. No. Oh no, not all of them, just this piece. 3. 1, 2, 3. There we go. Okay. We'll do the chamfer. Yeah. We'll do the add part, this part later, because I still have to do some extra work over here. Okay. What else do we need? So next, so we got that so far, and our lovely little chamfers on the corners, but now I need to do this screw, and you can't really see it well, but there is a little cut in here. Is that a rabbit? I don't know. Anyways, I got to chop a piece out, chop out some surface for that screw, and then the corners of the bottom surface are rounded, which we will chamfer, and do that next. So here we go. Like I said, the screw hole is important, the distance up. So I will measure from the flat surface up to that, which our reference surface is the grid plane, the blue one you see on the screen right now. Of course, it's 19 and a half. I do not like that. But half a millimeter is not going to make a difference on this. It's going to change the angle that the thing sits at slightly, but you'll never notice that because the size of this thing is so huge. So we're going to call it 20 millimeters from the bottom up to the hole that the screw goes in. So let's put that there for reference. This screw hole is 3 millimeters. And just to place it, I'm going to make it 4, and you'll see why. And then we'll change it to 3. It's easier to place the center of this object because the center of a even numbered object lands on a line, which is we're actually moving this. We need the center to be in a specific place, and then I can shrink it and leave the center in the same place. Which if I made this 3, then the center would be between 2 lines, and it would be, although it's possible to move it to where I want to, it's not exactly as easy. You'll see here in a second. So horizontally, though, it looks like it's 7, so that's going to be, yeah, 7-ish. So I said it was 20 up from the reference surface, and get over here. Our reference surface is the blue plane. So let's shift it down first to there. So the center is at 0. Now let's go up 20, which would end up being 18 high if we look at it. Let's see, where is that? Let's make it 18 up. Okay. Is that the center, or is that to the bottom? Oh, it's to the bottom again. Okay. This should be okay. Right now it's at 0. If I go to 20, then the bottom will be at 20, but I need the center at 20. So I would go down to put it at 18. So now the center is at 18. Right. And now this one needs to be 7 in from this edge. All right. That looks about right visually. Now we shrink this down to 3 instead of 4. And to do that, we got some fun tricks. So if I change this, right, if I change this to 5, for example, the corner that I selected will move, and the white corner will stay in a fixed place. So to get it so that the center stays in the same place, I need to take half of the difference. In this case, I need to get rid of 1 millimeter. I need to take half of it off of this side and half of it off of this side. So I need to take half a millimeter off of this side, 3.5. And then this side I need to go 3, and now the center is still 7 millimeters from the edge, but the thing is 3 millimeters wide. If I had done that with a 3 millimeter circle, that would have been 7.5 or 6.5 millimeters, and then I would have had to do some, trying to move a thing half a millimeter is unfortunately harder than shrinking it twice by half a millimeter. We need to do the same now for the vertical. And so to do that, I need to raise it up half a millimeter to 18.5, and I need to shrink it to 3. Because of the way this works, it looks a little different, but the same thing just happened. Where now the center is exactly where I want it to be. Yep. And so I'm going to leave that a little proud so it's easy to grab. Another trick I will show you. If I put this here on the surface, sometimes like right now it's easy to select because it's all black, but if I get just the wrong angle, then there's too much red, and now it's really hard. If I try to select, I select the red part now, so it's just easier to move it out a little bit, something you're going to have to grab and reuse. These are all just limitations of Tinkercad. If you're trying to do this in a more robust package, it takes a little bit more to learn it, but a lot of these things are much easier. All right. Yeah, leave that there. So that sits in a recess or a little pocket that is 3 millimeters deep, and the size is 6 by 6. So let's bring our square in. We need this to be 3 millimeters deep. Oh, I think the rain just started. Yeah, but I need it to be 4 so it can stick out 1 millimeter, so I can still grab it. Okay. And then I need it to be 6 by 6. I need to go up. Now let's see if we can show why that's such an annoying thing to grab in the wrong place. So right now, see that corner is exactly at the center of that square. If the center was like at 3.5 millimeters or 7.5 millimeters from the edge, this square would not, I wouldn't be able to center it up on that circle very easily. But as it is, since the center of the circle is on an even number or is on a line, grid line, or a whole millimeter, and the square is an even number of millimeters in size, the centers can line up easily. Alright, so I need that. Is that square? That's a separate depth, so I'm going to go ahead and add these together now. Now there's another one that is 10. As here, it lines up with that. It goes to the edge. It's 10 wide, and it is 1.5 millimeters deep. Ooh, 1 millimeter deep. 1 millimeter deep. 1.5. So I'm going to make it 2 just because it gives more clearance because the plastic isn't, when you 3D print these, isn't perfect. And I hate dealing with 0.5 millimeters. Again. Alright, so that lines up on this edge. I still need to stick out 1. We're going to call this 2 millimeters deep, which makes it 3 total. So it's because it sticks out 1 millimeter, right? I said it was 10 millimeters wide. Yep. So in this case, that's 10 millimeters tall. This needs to be centered on that again, which is good. This just overflows the edge, so we'll stick it out there. And okay, there's that one. I need to chop off a little bit off this edge, which is about 1 millimeter. It's a little less actually, but then there's a bevel there, so let's measure this distance. 12 millimeters wide exactly. So let's start out What is 12 millimeters wide? Yeah, this thing is 13, so it's 1 millimeter off the edge. Okay, so let's make this 3 also, and bring it out 1 to match the other one. Yep. And hang on just a minute. All right. Well, family moving around. So we've got that edge chocolate. That looks like it's a little big. I think it's supposed to, there we go, just 1. Okay, so we're chopping off 2 millimeters deep by 1 millimeters wide. We've got all those. That's everything, except for I do need to chamfer these corners too, and bevel, or bevel? Too many words. I don't know the difference. I lost my corner there. These are smaller, though. I'm going to take that and make it 1. Let's see. And boop. Is that 1? Yep, that's just 1. That's what I wanted. Make sure that's not too deep. Nope, that looks great. Let's do that other corner. We need to do the bottom one. Let's make this back to being 4 millimeters. No, yeah, I think. So then I can get the 1 millimeter I need without being on the edge. Yeah, that should do it. And then we need to flip these around. Which way? That way. Yep, just the bevel part. Yep, that'd be fine. Take this one. Same deal. Oops. We need to go down, do a little rotate. Yeah, I do want to sing this song. I'm not going to though. All right. 1, 2, 3, 4, 5, 6, and our target object 7. Join those, chop all the bits out. It looks lovely. It's kind of a complex corner there, but that's okay. We're going to chop that off with a chamfer as well. See which way do I need to turn that. That way. I do need to make this the bigger one again. Okay. And it's going to have to be as wide as that whole thing. And this one is back to being the larger chamfer of 2. Okay. I don't really want to chop that whole thing, do I? Actually, this one is a slightly different bevel on there to make that work right. But that's fine by me. Is it? Is it? Is it really? No, I should make it the better one. But if I go here, now it's really need that to be bigger, don't I? This one is not a 45-degree bevel like the rest. This one is unusual. It's kind of that, but it's more. There we go. That's actually more like what that angle is. In this case. Okay, yeah, because it needs to round that this little part up here also. Okay. All those other things with some bevels on them too, but man, that's going to be painful. Surprisingly, those don't have any. Interesting. Okay. Let's go ahead and put these on here. This 4 again. Let's see, this needs to rotate to don't put the number right. Tinkercad, why do you do that? You put the number right on top of my handle. I need that handle. Stop it. Grr. Tinkercad. Brr. That's an interesting one. How should I do that? Oh no, am I on the wrong side? Am I? What's going on here? I just built half of this backwards. Well, easily fixed. That's just this bevel part that's the bad part. Let's flip this around. Well, that was dumb. Okay, at least it's an easy fix. I like those. This is a curious one. One, two. If I do that, that's going to chop off a whole bunch. So, should I just chop off a whole bunch? Or do I modify that bevel to be not quite 45? Kind of like that. Yeah, I like it. That's all right. Yep, let's do that. All right. Let's on those. Oops. Let's join all of that. That's still just kind of a sharp edge. That was good enough. This one, though, I feel like it needs a little something. There we go. That's fine. Yeah, that's too much. That feels a little sharp still. Let's do that. Yeah, that's better. Okay. Still, but whatever. It'll print fine. Need to put a fillet here and round some corners. that. Okay. And let's chop some corners. I'm going to borrow you again. Make it forward. Make it whole. Make it shorter. Let's rotate this to here. Okay. Foot's asleep. We need another one. But this one needs something a little different because it goes all the way down. Interesting. Are these smaller chamfers? They are. These only use 1 millimeter, so I can do that. Uh-oh. I forgot that's the chamfer one. That's going to, that's the bevel. Wait. Huh? The bevel's on the wrong side. No, it's not. That's exactly the right side. That is correct. I need to angle that. Awesome. Well, that's doable. Okay. Let's just keep on going. Get that out there. We know what we want it to look like, so let's try to make it do it. We just need to level that out, right? We want this line to be straight. It doesn't have to be perfect. Looks pretty straight. Yeah. But I don't want it to chop so much there. I only want 1 millimeter, but that's not quite enough because of that bevel, or because of that angle. But if I adjust it now, oh, that's going to be a pain. Okay. Let's put that back and make this a bit bigger. I think I can do what I want then. Just eyeballing this. It seems close. Okay. Does that look the same? No. No, it doesn't. Man, I just... It's either too little or too much. Well, let's try. I don't like halves, but we're gonna have to make do. Ooh, come back here. All right, I think that is still too frickin' big. That's full there. No, I guess it does actually do by the. I didn't think about that. It's kind of based off of. Ew. No, we're not in the right place. Alright, I'm just going to have to try to move it the right amount, which is annoying. It wants to get it on a line. Ouch. You know what? That looks pretty good, actually. Let's just stick with it. Oh, I just realized. If I do that, because I have to bevel this bottom, it's got to line up with that too. So, it'll be fine. Well, there's a lot going on right now, so I'm going to break for lunch and come back and we'll resume here in about half an hour. See you soon.